Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Bismillahirrahmanirrahim. Welcome back. Problem 9.16. The statement of problem is that knowing that beam AE is a S200 by 27.4 roll shaped and P is equal to 17.45 kilonewton, length is 2.5 meter. A, which is given distance from point A to B, is 0.8 meter and E is equal to 200 gigapascal. So you have to determine the first part is equation of elastic curve for portion BD. So this is portion BD. You have to find the equation of elastic curve, and B part is deflection at the center of the beam. So at the center means C. So after applying load, the beam may deflect, or it will deflect like this. Clear? So you have to find the deflection, which is equal to YC. Clear? You have to find this. So let's start with the given data. So from given data, it is given that beam, which is equal to AE, is a short flange, which is S200 by 27.4 rolled shape. Clear? It is also given that P, which is point load, that is given as 17.5 kilo Newton. Length of the beam is given as 2.5 meter. Clear? And the distance A is given as 0.8 meter. Also the value of E is 200 gigapascal. Clear? So you have to find equation of elastic curve. Equation of elastic curve for portion BD. Clear? And in B part, it is given as to find the deflection at the center, which is YC, and we have to find this. So let's start solving this problem. The first step for solving this problem is that you have to find the reaction force, which is at RA and RB. Clear? And now you have a clear understanding how to find this reaction force. So you can find this reaction force by using equation equilibrium condition. Sum of all force along y direction is equal to 0, and sum of all movement about any point is equal to 0. So you can find this reaction force. I will not do it. I will just write this reaction force. When you solve this reaction force will come out to be RA, which is equal to RB, and that equal to P. Or there is an alternative method. You can see that if you consider portion ABC, so you can see the same load is given over on the right side, so it will be the symmetry. So again, this RA is equal to P, so RB is also equal to P. You can solve it in order to have clear understanding. Now we will move toward for finding the deflection. So as we know that we have this equation EI into d square y over dx square is equal to moment. Clear? So we will take the moment, we will section the beam first in this. Clear? And again over here. Clear? So let's do it for the first section. So if you section the beam at the first, so there will be a reaction force, and you know that this reaction force RA is equal to P. Clear? And when you cut the beam over here, so there will be a shear force V, and there will be a reaction moment M. Clear? And let this distance is X, because X is the distance from point A to anywhere where you cut the section. And this range is X is greater or equal to 0 and less or equal to A. So this first section is for X is greater than 0 and less or equal to A. So for that we will find the equation. So let this point is J. So sum of all movement about point J is equal to 0 and counterclockwise is positive. So you can see at point J there is a reaction moment M which is counterclockwise, so it will be positive. And due to this reaction force there will be a moment that will be clockwise, that is minus P into X is equal to 0. So it means that this moment is equal to P into X. Similarly, we will take the section at point 2 as well as, so, or you can section the beam of this portion BD. Both you can perform the both. I will take the section portion BD. So this is point B and this is point D. So if you section the beam at point BD, clear, so you can see due to this force or reaction force there will be a movement, clear. So at this point there will be a movement. Similarly at this point there will be again a movement, and this movement will be equal to P into A, because you can see this P into A is the movement. So we will have the equation of movement here is equal to P into A, clear. Now you have movement for both sections of the beam, so you can apply, this is, let's say, equation number 1, so you can apply this on equation number 1. So after putting the value of movement in equation number 1, this equation will be EI into d square y over dx square is equal to movement, which is equal to P into X, clear. Now you have to integrate it once, so you will get, after integrating it once, you will get EI into y is equal to half of px square plus c1. Let this is equation number 1, clear. Now again integrating equation number 1, we will have this equation, integrating this equation will give you dy by dx, clear. So we will, this equation will be used for the slope. If you integrate it again, so you will get EI into y is equal to 1 over 6 px cube plus c1x plus c2. That this is equation number 2. Again for this section of the beam you will also have to apply the same equation, EI into d square y over dx square is equal to moment, which is here you can see it is equal to PA. Integrating it once, you will get EI into dy by dx is equal to PAX plus C3. Yeah, that this is equation number 3. If you integrate equation number 3 again, so you will get EI into y is equal to PAX square over 2 plus C3x plus C4. This is equation number 4. Now you can see that equation number 1, 2, 3, 4 having unknown constant, that is C1, C2, C3 and C4. So we will find this unknown constant of integration by using boundary condition. So we have different boundary conditions. So we will, first boundary condition is that at x is equal to 0 we have y is equal to 0, clear. This is the first boundary condition. Again we have a second boundary condition is that at x is equal to L by 2 we have theta is equal to 0, because you can see there is a maximum deflection, so slope at maximum deflection is equal to 0. And at x is equal to a we have y is equal to some deflection, clear, and slope will be dy by dx, which is equal to theta. So we will use this we will use this boundary condition in order to find this unknown constant. So this was first section, which is for x is greater than 0 or equal to 0 and less or equal to a, and this portion is for x is greater than or equal to a and less or equal to L minus a, because this is portion BD. Clear? So this is portion BD. So if we will apply boundary condition, the first boundary condition is that at x is equal to 0, y is equal to 0, because it lies in this range. So we will put in equation 1. Equation number 2, because we have deflection is equal to 0 and this is the equation of deflection. So if you put y is equal to 0 and x is equal to 0, so you will have C2 will be equal to 0. Okay, then we will move toward another boundary condition. That boundary condition is that at x is equal to L by 2, we have theta is equal to 0, and theta by theta means we know that theta is dy by dx. So you will have to put it in equation 4. Why? Because x is greater than L by 2. Clear? And x is greater or equal to a. So L is a is 0.8 and L is 2.5. So L divided by 2 is greater than a. So we will use this equation of deflection. So put x is equal to L by 2 dy by dx is equal to 0. Again here we are using dy by dx, so this will be equation number 3, because this is the equation of dy by dx. So when you put x is equal to L by 2, clear, so dy by dx is equal to 0. So left hand side of equation number 3 will be equal to 0 and right side will be equal to PA into L over 2 plus C3 is equal to this 0. Clear? So you can take C3 is equal to minus 1 over 2 PA into L. So this is C3. Okay, for finding C1 and C4, what we will do is that we can see here that at x is equal to our third assumption, our third boundary condition is that at x is equal to a, we have deflection is equal to y. Clear? So what we will do is that you can see you have the range x is greater or equal to 0 and less or equal to a, and x is greater than or equal to a. So what we will do, we will put x is equal to a in equation number 2. Put into in equation 2. So when you put x is equal to a in equation number 2, so this become equal to ei into this left hand side, it will be equal to ei into y. Clear? And that will be equal to 1 over 6 p, and instead of x we will have a q plus c1 into a plus c2. That is equal to again if you put x is equal to a. Clear? And you can see in equation number, when you put x is equal to a in equation number 4, so the left hand side of this equation 4 and 2 is same, so this term will be equal to this term, so that will be equal to pa cube over 2 plus c3 plus c3 x plus c4. Clear? The fourth boundary condition we will be using is that we will put x is equal to a, so dy by theta will be equal to dy by dx. Clear? And we will put it in equation number 1 and 3. Clear? Because in equation number 1 and 3 both left side of these equations are same, so we will equate 1 and 3 after putting x is equal to a. So when you put x is equal to a in equation number 1, so I will write over here 1 over 2 pa square plus c1 is equal to this equation pa square plus c3, pa square plus c3, pa square plus c3. Clear? And you know that c3 is minus 1 over 2 pal, so I will write the value of c3 minus 1 over 2 pal. So when you calculate it, you will have c1 which will be equal to 1 over 2 pa square minus 1 over 2 pal. This will be equal to c1. Clear? Now you have c2 value, c3 value and c1 value. So you can put it c1 value, c2 is 0. You can put the c3 value which is over here. So from here you will get the value of c4, and c4 will be equal to 1 over 6 pa3. So you have all the unknown constant available. You can put it in equation 1, 2, 3 and 4. So you will get the required equation of slope and deflection for the respective section of the beam. As we have been asked to find the equation of elastic curve for BD, for portion BD. So definitely we will use equation number 3 and 4 in order to find the slope, and this equation is for deflection. So we will use equation number 4. After putting C3 and C4, we will get this equation will be like this. Y is equal to 1 over E I into 1 over 2 PA x square plus C3x plus C4. Clear? And if you put the value of C3 and C4, so this equation will be equal to 1 over 2 PA x square plus 1 over 2 PALX plus 1 over 6 PAQ. Clear? And if you take P common from all, clear, so you will have this deflection will be equal to P over EI into 1 over 2 AX square plus 1 over 2 ALX here plus 1 over 6 PAQ. Okay, one thing is that C1, C3 is a negative value. Clear? So this value will be negative. This will be minus. This is minus. This will be again minus. Okay? So this is the equation of elastic curve for portion BD. Now we have in second part we have been asked to find the deflection at the midpoint, which mean at x is equal to L by 2. So let this is equation number B. So put in equation B. So when you put the value of x is equal to L by 2 in this equation B, so you will get this deflection YC will be equal to P over EI, and this will be equal to 1 over 8 AL square, and this will be equal to minus 1 over 4 AL square, and this will be plus 1 over 6 A cube. Again here we have taken P as common, so no need to write over here, so it will be 1 over 6 A cube. If you further simplify it, because you can see that these two terms can be subtracted, so YC will become equal to minus PA over EI, and it will be equal to 1 over 8 L square minus 1 over 6 A square. Clear? So this is the equation. Of deflection at point C. For numerical value, you have the value of P, you have A, you have E, that is given above in the given data. All the values are present, only I is not available. So you can find the value of I in the appendix of S shape. You can see 200 by 27.7 is 23.9 into 10 raised to power 6 mm4. So you have I is equal to 3.9 into 10 raised to power 6 mm4, or it is equal to 23.9 into 10 raised to power minus 6 m4. So you have all the values, you can put it. Let me put this YC will become equal to minus P is 17.5 kilonewton, so into 10 raised to power 3, A is 0.8, GE was given as 200 gigapascal, so 200 into 10 raised to power 9, and I is 23.9 into 10 raised to power minus 6, and this L is 2.5 meters, so 2.5 square divided by 8 minus 0.8 square divided by 6. So when you calculate it, the value of YC will be minus 1.97 into 10 raised to power minus 3 meter, or YC is equal to 1.97 millimeter. And I have removed the minus sign, so this minus sign shows that the deflection is downward. I hope it's clear to you now and you have learned also. Thank you for watching.